Today we're going to look at absolute value inequalities. So we have absolute value on the left side, we have an inequality symbol, and then some sort of a number on the right side. If absolute value is less than something, remember that absolute value is like the distance from zero. So if they want the distance to be less than a units from zero, then they want x to be somewhere in between negative a and positive a. They want that distance to be from a and then in to zero. So they want this to be the type of inequality that looks like this, negative a to a. This is called an and inequality because the x value is larger than negative a and also smaller than positive a. I want you to think of this as less and than. When you see a less than absolute value inequality, I want you in your head to say, oh, that's less and than. Because if you see less and than, you'll know to set up an and inequality. Negative, opposite of the left side, less than x, less than positive of the right side. The other type is a greater than absolute value. Absolute value is greater than a. They want this graph to look like this. They want the distance from zero to be more than a units away from zero. So find the two places where you're a units away from zero, and go out from there. This is called an or inequality, and you'll see the word or right there in the inequality. I want you to think of this as great or. Greater. Just change greater to greater, and then you can remember how to set up this inequality. Okay, let's practice one. Example 1 is a less than inequality. So I want you to write on this slide, less and than. Less than inequalities we set up as an and inequality, a three-part inequality. The left side is the opposite of this number, less than stuff inside the absolute value bars, less than positive 2. So opposite of the right side, less than stuff, less than positive of the right side. How do we solve this type of inequality? Plus 9. So we get 7 is less than x is less than 11. We also need to graph the solution. Open circles for both of them, and we would shade in between. And inequalities are shaded in between the two numbers because negative 7 has to be smaller than the shaded stuff. The shaded stuff has to be smaller than 11. Should we set this example up the same way that we did the last example? No, because it is a greater than. So a greater, the first inequality needs to be exactly the same without the absolute value bars. So I'm going to write that. Exactly the same. No absolute value bars. So this one is x plus 3 is greater than or equal to 7. Do you see how I didn't change anything? All I did was take the absolute value bars off. Write the word or in between that and your next inequality. The next inequality, we keep the left side the same. We have to switch the absolute or the inequality symbol and take the opposite of the right side. So I'm going to highlight both of those things. Switch sign and opposite of right side. Okay. My Algebra 2 students always attempt this, and they always miss points. Or does not mean that you get to pick one. You have to solve both of these. You solve both of them, and you put or in between your answers. To solve the one on the left, we would subtract 3 on both sides to get x is greater than or equal to 4. For the other one, we would also subtract 3 on both sides and get x is less than or equal to -10. Put the word or in between those two answers, and that is your solution. Our x values either have to be greater than or equal to 4, or they have to be less than or equal to -10. And let's practice graphing this one, because I don't think we graphed any like this the other day. If you're lazy, you might accidentally do this. Did I just set up that number line correctly? No, -10 has to be on the left side. But because of how these are written, if you're lazy and not really thinking about what you're writing, it can be very easy to rush and just put 4 on the left when that's not where it should go. So let's do this one in blue. Greater than or equal to 4. We would have to do a closed circle at 4 and shade to the right. And we will do this one in green. Closed circle at -10, shaded to the left. Or inequalities always point in opposite directions. And inequalities are shaded in the middle, or inequalities are shaded on the outside and point away from each other. Do you see anything different about this example?
Yes.
Do you see the -6 on the right side? Anytime you see a negative on the right side of absolute values, I want you to stop and think about it. Yesterday, we did absolute value of stuff equals a negative number, like -2. We said that was no solutions because absolute value always gives you a positive number, and a positive number can't equal a negative number. So anytime you see a negative number on the right side, you need to stop and think about it. Some people would say just memorize the next 2 rules, but honestly, it's easier just to think about it. Absolute value. On this left side, absolute value is always going to give us a positive number. Greater than -6 is a negative number. Think about that statement. Positive is bigger than negative. Is that a true statement?
Yes.
Positive numbers will always be bigger than negative numbers. This is always true, and that means that there are infinitely many solutions. Basically, whatever x value you choose to put in there, it is going to create a true statement. I could pick +10. 8 minus 50 would be a negative number. That would turn into a positive number when you took the absolute value, and that would be bigger than -6. No matter what x value you put in there, it will always be true. Now let's look at example 4. Again, we see a negative number on the right side. Whenever you see a negative number on the right side, stop and think about it. Absolute value is always going to give you a positive number. So I'm going to turn this statement into words. The left side is going to end up being positive. The right side is negative, and they're connected with a less than or equal to symbol. Can a positive number be smaller than a negative number? No, this is not possible. So there are no solutions. Honestly, you're going to hope for these problems on the test, because if there's a negative number on the right side, you don't have to do very much work. You just have to think about, is it possible or is it not possible? Okay, example 5, we have a little bit of work to do, and I do want to do this entire example just to make sure we have it. What do you think we need to do first? Subtract 4. So absolute value of 4 minus 3x over 2 is greater than 1. This is a great or inequality. So we need to write two separate inequalities. So over here, I'm going to write two separate inequalities. 4 minus 3x over 2 is greater than 1. That one is exactly the same without the absolute value bars. The other one, switch the inequality symbol, take the opposite of the right side. Okay, let's solve the one on the left. I'm going to zoom in a little bit so we can all see these. What should we do first in the process of solving? Multiply by 2. And I'm going to do that over on the right side too, just so that it looks a little bit better. Okay. Now we need to subtract 4. And then divide by -3. What happens when we divide an inequality by a negative? Flip the sign. So x is less than positive 2/3. For the other one, kind of mimic the same steps. We subtract 4. Divide by -3. When you divide by a negative, you have to flip the sign. X is greater than 2. Put the word or in between your two answers, and then graph them. And you can seriously just put 2/3 and 2 like that on the graph. Remember, 2/3 is 0.67, so it's definitely smaller than 2. This actually flips it around and makes it easier for us to graph. Here's your assignment. It starts on page 155. This is actually 3.7 assignment part 2.